Welcome to part 2 about linear sequences. So, how do we find specific terms in a linear sequence? Let's try finding the first 5 terms in the sequence given by the nth term rule 3n plus 12. You find a specific term by replacing n with the number of that term. So, for example, to find the first term, you have to replace n with 1. 3 times 1 plus 12 equals 15. So, the first term is 15. Similarly, for the second term, you have to replace n with 2. 3 times 2 plus 12 equals 18. So the second term is 18. The same way we get the third and the fourth term, ending with getting the fifth term by replacing n with 5. 3 times 5 plus 12 equals 27, so the fifth term is 27. Now, try to find the first 5 terms in the following sequences. Pause the video and resume when you are done. Then I will show you the answers. Alright, so these are the answers to the task. Now that we know how to find specific terms in a linear sequence using the nth term rule, let's see how do we check if a specific number appears in a given linear sequence at all. Consider this example. Does the number 48 appear in the sequence given by the nth term rule 3n plus 12? To find out, we have to set up an algebra equation. On the left-hand side, we put the nth term rule given, and on the right-hand side, the number we are checking for, in this case, 48. Solve the equation for n as you would any other such equation. If n turns out to be an integer, as it is in this case, the term does appear in the sequence. The result shows which term the number is in the sequence. So in this case, the number 48 is the 12th number in this sequence. On the other hand, in the second example, we are asked to check if 70 is in the sequence given by the nth term rule 3n plus 12. Again, put the nth term rule on the left-hand side and the number we are checking for, 70, on the right-hand side. Solve the equation. As a result, we will get 19.3, which is not an integer. Therefore, 70 does not appear in this linear sequence. Please find out if the following terms appear in the sequences. Pause the video and resume when you are done. Then I will show you the answer. Alright, here is the answer. The only example where the answer is no is F. This is because when you solve the equation, n equals 9.5, which is not an integer. Now we know how to check if a specific number appears in a given sequence. Time to combine and recap what we have learned today. Sometimes we can find linear sequences in pictures. Consider the following three pictures, which we will consider to be terms 1, 2, and 3. When we count the number of tiles, 2, 5, and 8, we can notice that this is a linear sequence as well, with difference 3. To get the nth term rule, we multiply n by the difference, which is 3, then add the zeroth term. What would the zeroth term be? Again, do to the first term the opposite of what you would do in order to get the next term. 2 minus 3 equals minus 1. This means the nth term rule is n times the difference, which is 3, subtract 1, or 3n minus 1. Now, a task for you. Given the pictures on the left showing chairs around a desk, work out a formula linking the number of chairs to the number of desks, and how many chairs would be needed for 10 desks. Pause the video now and resume when you are done. Then I will show you the solution. When we put the number of chairs at each desk in a table, we can notice that there is a linear sequence with difference 4, so we can get the nth term rule. N times the difference, which is 4, plus the zeroth term. For the zeroth term, we calculate 6 minus 4, which is 2. Therefore, the nth term rule is 4n plus 2. Now, to find out how many chairs would be needed for 10 desks, we replace n with 10. 4 times 10 plus 2 equals 40 plus 2 equals 42. So, for 10 desks, we need 42 chairs. Thank you for watching and good luck.